Okay, so now we're going to use a half angle formula to find an exact value for the sine of 15 degrees. So we're not interested in using a calculator here. We're going to use a half angle formula. So let's write the formula. Sine alpha over 2 is equal to plus or minus the square root of 1 minus cosine alpha over 2. So that was the half angle formula for sine. And then what we're going to do is we have to put something in for alpha so that alpha divided by 2 will equal 15. So it's going to be 30. We're going to go with degrees here. 30 degrees over 2. Okay? So you're replacing, what you're saying is, I'm going to let alpha equal 30 degrees because 30 divided by 2 is 15, right? Okay. So that's the idea there. And then that gives us plus or minus the square root of 1 minus cosine 30 degrees, I'll put it in parentheses, over 2. Okay, so now a couple things. First of all, you notice we have the plus or minus, right? Well, we know that if it's 15 degrees, you're in the first quadrant, so it's going to be positive. So you can drop the plus or minus because it's going to be positive. Okay, so we'll stop doing that. 1 minus, and then we know the cosine of 30 degrees. It's the square root of 3 over 2. And then all of that's over 2. So that's kind of a mess. So we want to clean it up a little bit. It's going to be 2 minus the square root of 3 over 2, all over 2. And then think about taking that and multiplying by 1/2. So you'd have the square root of, I'm using a lot of room here, 2 minus the square root of 3 over 4. But then I can take the square root of 4. So I'm going to say the square root of 2 minus the square root of 3 all over 2. And I would leave it like that. And that's going to be the sine of 15 degrees. Okay? That's an exact value. We didn't do any decimal approximation or anything. It's kind of weird because you have a square root inside a square root. We don't see that all the time. And you might be thinking, well, is there something I could do to simplify it? No, not really. I mean, there's some things you could do, like write it with a rational exponent notation, but I wouldn't bother. I would just leave it like that. Okay, now for those of you thinking outside the box out there, you might have looked at sine 15 degrees, and maybe you were thinking, so this is like another thought, this is my thinking cloud, maybe you were thinking, hey, sine 15, isn't that 45 degrees minus 30 degrees? It is. Okay. And couldn't I use then a difference formula for sine? You could. And there's nothing wrong with that. It's just a different approach. If you did that, your answer would not look the same, okay, as what we did here. And that's okay. The value, the decimal approximation would be the same. It would just look different. Okay, so we didn't do that. It's not that it's a bad idea. We just didn't do it. We were using a half angle formula here. So that's why we did it the way we did it. Okay, so just if you were wondering, I just throw that in. So if you weren't wondering, just ignore that part. But okay, yay, we used a half angle formula and we got the answer. Okay.